Have you ever looked up at the night sky and wondered what it would be like to navigate through the stars? To journey past the planets and explore the cosmos with the flick of a finger? What if you can build this interactive galaxy navigation by yourself? Yes, let me show you how you can turn complex physics and beautiful design into an experience you can hold in your hands. Think of this app as a few main layers built on top of each other. At the very bottom, we have the space backdrop with all the stars. Then we add the sun. On top of that, we lay down the faint orbit lines. And finally, on the very top, we place the planets themselves, which are clickable widgets. All right, let's start with the main widget, Galaxy Navigation. This is a stateful widget because its state, like the camera position and the time, is constantly changing. The variables ticker, T, start time, camera, and camera vel are all essential for animating the scene and handling user interactions. We're using a ticker here, which is a low-level Flutter tool for running animations that don't depend on a widget's properties. The ticker manages the animation loop, with T acting as the main time counter for calculating planet positions. The camera and camera vel variables control the screen's pan and inertial movement in response to user drag gestures. The planets list is a fixed data model that contains all the necessary information for each planet, such as their name, color, size, orbit radius, and speed, which are used to render and animate them correctly in the galaxy. In init state, we start a ticker. Inside this callback, it calculates the T variable, which serves as the continuous, time-based input for animating the planet's orbits. The code also manages the camera's movement. It updates the camera's position, camera, based on its current velocity, camera vel, applies a decay to the velocity to simulate friction and inertia, and uses lerp double to gently spring the camera back toward the origin over time. This creates a smooth, dynamic effect for the entire scene. In dispose method, it is crucial to stop the ticker, preventing memory leaks and unnecessary processing. In build method, first we calculate the screen size and a dynamic center point for the solar system that shifts with the camera's position. The entire view is wrapped in a gesture detector, which allows the user to pan the scene by updating the camera's position and velocity. The main layout is a stack, which layers several elements from back to front. A static, deep space background, a dynamic starfield, the pulsating sun, and the orbital paths. These visual elements are all drawn efficiently using custom paint widgets with their respective painters, which use the T and camera variables to create animations and parallax effects. On top of these painted backgrounds, we loop through our list of planets and create a positioned widget for each one. The position of each planet is mathematically calculated on every frame based on its orbit radius and the current animation time T, simulating its movement around the sun. Each planet is a hero widget, enabling the fluid fly-through, transition to the details page when tapped. The flight shuttle builder within the hero tag customizes this animation, making the planet glow as it moves. A gesture detector on each planet widget triggers the Open Planet function, which handles the navigation and transition to the planet details page. The Open Planet method handles navigation to the planet's details page with a custom, subtle transition. Instead of a default screen transition, we use PageRoute Builder to define a custom animation. The Transitions Builder function then creates a composite animation where the new page fades in and slightly scales up from 95% to 100% of its size, creating a smooth fly-through effect. The transition duration and reverse transition duration control how long it takes for the animation to play when the page is pushed and popped, respectively, giving the user a polished, immersive experience. The planet widget is a stateless widget responsible for rendering a single, visually detailed planet. It uses a container with a circular shape to represent the planet's body. The 3D-like appearance is achieved using a radial gradient that blends different shades of the planet's color, creating a sense of depth and lighting. A box shadow is added to produce a glowing effect, with its blur intensity, glow, being a customizable parameter. Finally, the widget displays a small icon at its center, representing the planet, making it a complete and reusable component for the galaxy view. The Planet Details page is a stateful widget that displays the details of a selected planet with a dynamic, animated card. When the page is first loaded, an animation controller starts to animate a morphing effect. The layout uses a stack to place elements on top of each other, including a background gradient, a star field, a back button, and the hero planet that flew in from the previous screen. The most complex part is the morphing card at the bottom, which uses an animated builder to smoothly transition its height and border radius from a small circle into a large, rounded panel. It also uses a backdrop filter to apply a frosted glass effect and displays the planet's info using the Planet Info widget, creating a polished and interactive user experience. Inside this card, we have the Planet Info widget. The Planet Info widget is responsible for displaying the details of a selected planet on the Details page. It receives a planet object and a progress value, from 0 to 1, from the parent animation. The widget's main content, the planet's name, information, and data chips, is wrapped in an opacity widget that uses the progress value to smoothly fade in the information as the animation progresses. The chip widget formats the specific data points like orbit radius and size into aesthetically pleasing, stylized containers. This modular design makes it easy to present and manage the planet's data. Inside the build method, we are using 3 CustomPainter for the starfield, sun, and orbit. So, what are these custom paint widgets doing? They're drawing things directly onto the canvas, which is super efficient for complex, non-interactive visuals. The Starfield Painter efficiently renders a dynamic, layered starfield. The paint method creates the effect by calling a helper function paint layer 3 times, each with different parameters for density, speed, blur, and opacity. This layering approach creates a parallax effect, where the stars in the foreground appear to move faster than those in the background as the user pans the camera. The paint layer method uses a seeded random generator to consistently place a calculated number of stars, applying a subtle horizontal drift over time and a blur to simulate glowing. By giving each star layer a different parallax factor and having them drift at different speeds, we create a sense of deep space and motion as the camera moves. The should repaint method is optimized to only redraw the stars when the time or camera parallax has changed, ensuring high performance. The orbit painter is a bit simpler. It efficiently draws faint, semi-transparent white circles for each planet's orbit using the canvas.drawCircle method, with the radius determined by each planet's orbit radius. The should repaint method is optimized to only redraw when the center or planet's list changes, ensuring performance remains smooth. And the sun painter is all about creating that beautiful, glowing sun effect. The paint method draws 2 concentric circles to create the effect, a large blurred outer glow and a smaller, sharper inner core. Both are painted using radial gradient shaders to create a realistic, multi-toned light fall-off. The outer glow's size is animated by a pulse value calculated using the sign of the time variable, which makes the sun appear to throb and pulsate. The inner core is slightly blurred with an image filter to add a subtle fiery texture. This separation of the glow and core allows for a highly customized and performant animation. The should repaint method ensures the sun is only redrawn when the camera position, center, or the animation time changes, optimizing performance. By combining simple concepts like custom paint, gesture detector, and stack, along with some clever use of hero and animated builder, we can create a really stunning and interactive user experience. Now that you have the knowledge to build your own cosmic navigator, the galaxy is truly in your hands. So go on, start your own interstellar journey.